We finally come to the last section where I'm going to try to wrap up the whole design patterns in Java course. We'll take a look at some of the missing patterns I didn't cover and why I didn't cover those patterns. I'll mention some of the Java implementation construct that may change the way that you might implement some of the patterns. And I'll recommend some things that you ought to read up on to become more fluent in design patterns. The Gang of Four book on design patterns covers 23 different patterns. In this course, we only covered 15 of the patterns. Some of the missing patterns are in the catalog of structural and behavioral patterns. We actually covered all of the creational patterns in one big swoop, but we missed out in the structural patterns bridge and flyweight. And in the behavioral patterns section, we missed out chain of responsibility, interpreter, iterator, mediator, memento, and visitor. Let me quickly discuss some of those patterns and perhaps also why I didn't cover them. In the structural patterns section of the Gang of Four book, we have the pattern called bridge and flyweight. Now, bridge is about how you separate interfaces from implementation, where you design an interface between maybe two sectors of your implementation or two sections of your implementation, and you define an interface that shows how these two sections interact. Now, I didn't cover that pattern simply because it hasn't really become a pervasive use of design vocabulary, in my opinion. Flyweight is a strategy to extract common information between a set of smaller objects into a single abstraction. This is often used to save memory. It's a very practical pattern in the cases where this is useful, where you need to save this memory, but it's also not a very pervasive pattern, and that's why I decided to skip it. I also skipped quite a few patterns in the behavioral catalog. Chain of responsibility, I was thinking I should include. However, again, it's not that commonly used, but it's all about delegation where you use some natural structure of object that you change together so that when something happens in one object, you can propagate or escalate or delegate, if you want, some request through this chain to find the appropriate handler. It is actually a fairly practical pattern. I would recommend you read up on it. It's used a lot in user interfaces for doing things like context sensitive help, for instance, but I would recommend that you read up on it. The interpreter, on the other hand, is a pattern that works in a very small domain. The idea here is to build a parser that uses the natural class hierarchy that makes up the language being parsed. And you can see this being used in parser tools such as Antler and so on to do parsing. It's very rare that someone is building this without some parser tool. So I decided to skip it again because it's not very widespread. The iterator is a very commonly used pattern. It's a pattern where the algorithm to access a collection is abstracted away from the client to make it easy to access various implementations. So, for instance, you can access a tree structure the same way as you do a linked list or an array. The mediator is a pattern used quite often in user interfaces, and you have actually patterns that are built up around that, things like model view presenter and so on, where the model and the view is being mediated by the presenter. Memento is a nice pattern. The idea here is to have a client hold a state on behalf of a service that is naturally stateful. This is what we often do in web world by using things like cookie, for instance. It's a very practical pattern. It's probably going to be a very important pattern in the world of massively scalable systems where the client is holding some information that they will pass back to a stateless service so that that stateless service can read where they were at the last time the client connected. Visitor is a very interesting pattern, one that is very often misunderstood and very often overused in the places where I see it. The idea of a visitor was basically to solve something called multi method or multi type dispatch. So, this is when you have an algorithm that depends on more than one type. It's a very commonly misunderstood pattern. It's one that is an intellectually challenging thing to learn. So, recommend that you read up on that one. One thing that is interesting when you read up on all the other patterns that I have covered is that Java has very specific issues in the way you implement it. Now, there are things that weren't commonly available when the Gang of Four wrote the Design Patterns book that you may want to take advantage of. So, we have things like reflection, for instance, in Java, which allows you to get to the class or get to some of the metadata behind objects. And that can often be used very effectively in creation. You have things like dynamic proxy, which is a very interesting way of implementing some of the pseudo delegation patterns that we mentioned in one of the chapters. Dependency injection, also common, particularly when it comes to things like singleton, for instance, that could be a very useful feature. And you have things like Aspect J, which is very, very powerful and allows you to do a lot of interesting things around things like proxies, but also mediation and creation of objects and so on. So that's another interesting Java specific issue that you might want to take into account. And also, Java 8 introduces things very close to the concept of closure. And also, things like aspects are almost back into the language in Java 8. So there are a set of very specific Java implementations that you want to take advantage of when you implement some of these patterns. The main source for the reading should be the Gang of Four book, the book called Design Patterns, Elements of Reusable Object-Oriented Software, as depicted on the right-hand side. And I would recommend to learn all the patterns in that book. It defines the main vocabulary used in design, and it's the original source. Now, some people find the book extremely abstract and hard to read. I think what you need to do is to break it up and study one pattern at a time, but I'll come back to that later in this section. I wanted to mention the Head First book on design patterns. It's easier to read, a lot more graphics in it, and it has some code examples that might be useful. Take a look at it in a bookstore and see if that suits your style better. So I decided to pick this book by a guy called Trygve Renskaug, who is a Norwegian computer scientist working with objects. It is unfortunately out of print, but you can, if you search on his name, Renskaug, working with object, you can find his manuscript that he has put out as a free PDF version. What's interesting about this book is it makes it very easy to describe patterns. His treatment of roles is very interesting. I was once working with a tool that he created that unfortunately is no longer available. It was a tool based on the method called ORAM, and I found it extremely useful in the way I want design and also the way I apply pattern in a practical world. So I would actually recommend this book very much to understand how to synthesize patterns together. When you pick up one of these books and you want to study the patterns and learn these patterns, I would highly recommend that you do that in groups. I like brown bag lunches. I used to do that with my employees to learn how to apply the patterns. We used to do one pattern at a time, and we used to pick someone to read up on that pattern, study it in detail, and then explain it to the group. And then we would discuss where and if a pattern may be applied in our domain. We tried to contrast the pattern being discussed with other patterns that we had learned. This is a very efficient way of learning patterns. I would highly recommend it. I want to get back to this concept of if a pattern should be applied. And I want to do that with a short story that I'm going to draw. There once was a kingdom where the king had four heirs. And what the king was afraid of is that once he died, that these four heirs would start arguing. His kingdom was of a geometric shape that looked something like this. Now, think of this as three perfect squares put together. Now, the king has summoned you to solve this problem, and he knows that his heirs will start arguing over the land and maybe go to war unless you can figure out a way to split his kingdom into four pieces. And these pieces have to be consecutive. So, no open gaps, no fragmentation. This turns out to be a problem that isn't all that easy. If you think about it for a long enough period of time, you would actually solve this one. The solution to this is basically to split it in a way, something like this. And now you get four pieces of equal size, shape, and all consecutive. Now, this problem is really just a warm up. The harder problem that I wanted to show you was one in which we changed the parameters a little bit. In this case, we're going to have 5 heirs and we need to split it into 5 pieces, say a different kingdom, a different king. This king has a perfect square as their kingdom. Now, how would you solve that? Now, of course, the solution to this problem is very trivial. And if I had given you this problem first, you would have had no issues. The solution is simply just divide it into 5 vertical or horizontal. So, what can this exercise teach us about pattern? What I've found to be the most common mistake when people are using patterns is that they're overusing the patterns. You know, the classical thing, the one with a hammer tends to look for problems involving nails. This is what we need to try to prevent. When I give someone that has just learned a set of patterns a problem, they look for places where they can apply that pattern. And that's good as a mental exercise, as a learning exercise. However, it often complicates a design where there is a very simple solution available to you, a very trivial one that anyone can understand. Some designers tend to say, well, we could do that by using X pattern and combine it with Y pattern. And they create a structure that is overly complex. It is the most common problem I see. So patterns are great, but they have to be used when you have a problem to solve that matches the problem description of the pattern itself.